Good day, everyone. Today we'll discuss programming and software. In this lesson, we will discuss how to use computers as a tool to obtain numerical solutions to a given engineering model. There are two ways in using computers. This is to use available software or to write computer programs to extend the capabilities of available software such as Excel and MATLAB. Engineers should not be too limited. It is important that they should be able to do both. Computer programs are a set of instructions that direct the computer to perform a certain task. To be able to perform engineering-oriented numerical calculations, you should be familiar with the following programming topics, such as simple information representation for constants, variables, and type declaration, advanced information representation for data structure, arrays, and records, mathematical formulas, assignment, priority rules, and intrinsic functions, input or output, logical representation, we have sequence, selection, and repetition, and last is modular programming. We have for functions and subroutines. Assuming that you have some prior exposure to programming, we will focus our discussion on the last two topics. Structured programming is a set of rules that prescribe good style habits for the programmer. Today, it is recognized that there are many benefits to writing well-organized, well-structured code. Aside from the obvious benefit of making software much easier to share, it also helps generate much more efficient program development. That is, well-structured algorithms are invariably easier to debug and test, resulting in programs that take a shorter time to develop, test, and update. The key idea is that any numerical logarithm can be composed of using three fundamental structures, that is sequence, selection, and repetition. By limiting ourselves to these structures, the resulting computer code will be clearer and easier to follow. Next is the modular programming. This approach is where computer programs can be divided into subprograms or modules that can be developed and tested separately. The most important attribute of modules is that they as be independent and self-contained as possible. In addition, they are typically designed to perform a specific, well-defined function and have one entry and one exit point. As such, they are usually short and highly focused. Modular programming, its advantages are it is easier to understand the underlying logic of smaller modules, they are easier to debug and test, facilitate program maintenance and modification, allow you to maintain your own library of modules for later use. Excel. Excel is the spreadsheet developed by Microsoft Incorporated. Spreadsheets are a type of software that allow the user to enter and perform calculations on rows and columns of data. When any value on the sheet is changed, the entire calculation is updated. Therefore, spreadsheets are ideal for what-if sorts of analysis. Excel has some built-in numerical capabilities, including equation solving, curve fitting, and optimization. It also includes VBA, or Visual Basic for Applications, as a macro language that can be used to implement numerical calculations. Finally, it has several visualization tools such as graphs and 3D plots that serve as valuable adjuncts for numerical analysis. MATLAB. MATLAB is the flagship software product of the MathWorks Incorporated, which was co-founded by the numerical analysts Clive Moller and John N. Little. As the name implies, MATLAB was originally developed as a matrix laboratory. To this day, the major element of MATLAB is still the matrix. A variety of numerical functions, symbolic computations, and visualization tools have been added to the matrix manipulations. MATLAB has a variety of functions and operators that allow convenient implementation of many of the numerical methods. Programs can be written as so-called M-files that can be used to implement numerical calculations. The use of MATLAB is closely related to programming. That ends our lesson on programming and software. Thank you.